beyond mobile, powering embedded devices with Flutter. And well, first of all, an agenda. We will talk about me, only very short. Then we'll talk about a problem I have in my everyday life. Maybe you have the same problem. It's a very serious one. We're going to deal with that problem today. And we're going to use Flutter, embedded Flutter, to deal with that problem. So, about me. Yeah, hi, my name is Moritz. I'm a GDE for Flutter and for Dart. I'm the co-founder of Snapp X and Snapp Embedded, which are both Flutter companies based in Munich. I am also the co-organizer of Flutter Munich. So if you ever want to come over to Germany to give a talk or just visit one of our meetups, feel free to hit me up, to write me on Twitter, X, or LinkedIn, or if you find my phone number somewhere, you can try to call me. Yeah, we'd be happy to see you over in Munich as well. That's it with me already. That's enough. My problem. Very serious problem. I like M&Ms. Like I don't like M&Ms. I love M&Ms, and that's the problem. I eat too many of them. So this wasn't a problem for the last years of my life, but it's becoming a problem now because in the evenings, and if I open a pack of M&Ms, yeah, I have no self-discipline. It's gone. 10 minutes, 20 minutes, it's gone. So I'm a Flutter developer. What can I do about that? Well, I'm going to use Flutter to deal with that problem. And how I'm going to deal with that is what I'm showing you today. No worries. So step one is the hardware. What are we using? What can we use? So we have this problem. We know too many M&Ms. We have to do something about it. Let's first look what we can find in the drawer next to our desk. So opening up the drawer, and what do we have in there? Oh, thankfully, you already can see it in here. Raspberry Pi5, some kind of food dispenser or cereal dispenser. It's not working now. 1 second. Oh, yeah, let's go back. Here we can see it in a big overview. We have a touch screen. We have some kind of cereal dispenser. We found a Raspberry Pi 5. We found a small PCB to control some servos. We found some servo motors. So let's go through it. First, we have a Raspberry Pi Model 5 with 4 gigs of RAM. That's not even the big version. The big version has 8 gigs of RAM. You can try it by yourself. If you think the performance of this one is enough for an embedded Flutter application, you can come here afterwards and click it. I mean, you already see the result of this talk. Next thing we have is, this capacitive touch display. It's a wave-share display. Nearly 12-inch, nothing special. It connects to the Raspberry Pi via USB, uses HDMI and uses USB, just works out of the box with Raspberry Pi OS, with the Raspberry Pi, and really not much to say about it. We have this food dispenser where I'm not going to tell you where I bought it. You have to figure that out by yourself. The very special about this model is the material composition of 50% plastic, 40% plastic, and 10% plastic. I think that's important. Works very, very good for our purposes. We have this servo controller by Adafruit, PCA 9685. It's a 16-channel servo controller, and it basically, if you want to control the servo, you could even do that directly with the Raspberry Pi, but the normal way with microcontrollers is use one of the bus systems you have with microcontrollers, the Raspberry Pi as well. Like in this case, the I2C interface. You then connect some other chip that translates your signal to the hardware you're using. So with this one, we could connect up to 16 servos, but one will work as well. Then we have our servo motor, Spring RC, just a very normal servo motor. They are always, most of the normal servo motors are PWM, pulse width modulation controlled. And the important thing about this one, it's a continuous rotation servo. What that means is with a servo, if it's normal, would be 180-degree servo. If you give that one a high signal or the highest signal possible, then it will just go to the plus 180 degrees. If you give it the lowest signal possible, it would go to minus 180 degrees. If you give it the signal right in the middle, you'll have it in the middle. With a continuous rotation servo, you give it the highest signal and it will go as fast as possible clockwise. Same goes for the other direction. It would go as fast as possible counterclockwise. And with the middle signal, it will just stand still. This is obviously what we need here to drive our food dispenser. So then we just need a little thing more here. So we sit down and we build some parts for the 3D printer. So we just get there, go on our computer at an evening, start designing some stuff, put in some holes, and here another hole, designing what you're seeing here already. Getting everything ready, exporting it to our 3D printing software. Exporting it, importing it to the software, printing it, and I'm going to be silent for a minute. We can see now here the printer in action. This always takes ages, and as you can see, obviously, there's already some more parts in the printing within with it. So I'm going to wait until that's finished. And we have everything for our M&M dispenser finished with even a dash sitting right next to it. So now, first nearly 10 minutes of this talk, and I didn't even talk about Flutter, but that comes now. Let me just, if I get this thing here. So the solution part 2, now we get to embedded Flutter. So when we start with embedded Flutter, it becomes weird. Because normally, if we want to develop Flutter for iOS, for Android, for web, we just use Flutter, right? But if we Google embedded Flutter, what are the solutions there? How does it work? By the way, those numbers are a little bit old. They are higher now. I think this from October last year. We'll get different options, and we don't know why there are different options. So we need to understand. That. Is that all Flutter, or are those different versions of Flutter? Yes, it's all Flutter. It's just different embedders of Flutter. To understand that, we need to understand the components of a Linux system, a Linux-based system where this is running on. In the embedded world, or especially in the scenarios where Flutter can run on an embedded device, we mostly have a Linux stack. And on this Linux stack, we have, I wouldn't even say software components, because there's, as you can see, there's also the GPU in it, but there's multiple components that influence what we can use what we can use in the end with our software. So we have the GPU, and in our first example, we have the GPU, we have a Vivante GPU, we have the Vivante GPU driver, which is proprietary by the GPU supplier, which makes sense, but more to come on that part. We use OpenGL-ES, Ubuntu Core as display server protocol Xorg. You don't need to know all of these things. It's just an example. But in this example, we can just use the very normal Flutter Linux embedder. It works with GTK3, with GTK3. For this example, as with the Raspberry Pi OS, we can use Flutter Linux as it is. It works. Everything is there. Performance-wise, you just have to test it. You find it out, you use the app, and you see, is it enough? Is it not enough? Well, in this case, I would say it's enough, but you'll find out on your own. Another example where we can't use Flutter is this example. That's very often used as well. Now we have the GPU. We have, again, a Vivante GPU, but this time we have EtnaViv. This is the interesting thing. This is an open source reverse engineered driver for this proprietary thing that outperforms the original driver in some cases, but it's not shipped by the chip manufacturer. So here things start to get crazy already. And a lot of production embedded devices use this driver instead of the proprietary driver. We use OpenGL, yes. We use Yocto, which is basically a very tailored Linux build, also something that's very common. You just use the components of a Linux system that you really need. And now the next thing is we use Wayland as our display server protocol. And the most important thing is we don't have GTK or GTK3. Those are libraries that offer us things like tabs, minimizing windows, and so on. We don't need that in most of our embedded applications, but the original Flutter embedder uses it, and therefore we can't use it. We now can here use the IVI home screen, which is made by Toyota, and this one is. Well, I just need to drink something very quick. Yeah. Thank you, Chate. So in this case, we couldn't use the original Flutter. We have to use IVI home screen. So it's not even about performance. It's really about what we can use. Another example. Thank you. Another example here would be Flutter Pi. We have another stack of components here. We again use EtnaViv. We don't have GTK. We don't have GTK. We don't even have a display server protocol here. That's used very often as well in the embedded world. We couldn't use embedded Flutter here. But for our first example here, we can just go with Flutter. We have Raspberry Pi OS. We want to test our first steps here. Not a problem. We just go with Flutter. And to do that, we developed something. It's an open source tool, and showing it with live coding would take too long. That's why I pre-recorded it and fast-forwarded it in some points. And you can see here, you can just download from PubDev Snapp CLI. Here I use override. You don't need to use that, obviously. And I'm sorry, you maybe hear it. My voice just sounds really, really weird. I don't know what it is right now. Sorry, I hope it's okay. So you can use Snapp CLI. You use the bootstrap command. You run and enter the IP of your Raspberry Pi in there. And it automatically connects to the Raspberry Pi through Wi-Fi and installs Flutter, sets it up as a remote debugging device, does everything for you. And yeah, as you can see, that's as easy as you can install your Flutter on an embedded device. Sorry, my voice is really weird right now. So, next slide. Now, it not only install Flutter on the device, as you saw maybe at the end, it also added it as a custom device on the host machine. And now the interesting thing and what that means is, we'll see here, if we now click Snapp CLI devices, we can see that our Raspberry Pi 5 is listed in there. So on our host machine, if we have the Raspberry Pi 5 in the same Wi-Fi, we can just start a new Flutter project. We start Visual Studio Code. And as you can see here, or as you maybe saw, it was really fast, we can select the Raspberry Pi 5 just as a debug device, just as with a mobile phone with everything. We click build, it takes a few seconds, and I'll not spoiler it. The application will start on the Raspberry Pi 5. It will work through Wi-Fi. It's easy as that. You have hot reload, you have the dev tools, you have everything there. So when you can use Flutter just as it is, or even with the custom embedders, which you only need if you're on special hardware or if you're going out in production, it's easy as that. And you can debug it and build the app for it, just as you would with an iOS or Android device. So the UI development itself is nothing you would know. It's basically just here, you can see a little part of it fast forwarding. I would develop it for myself, debugging on Mac OS. It's just faster. I think a lot of you guys are doing it because, yeah, the iOS builds take longer, the Android builds take longer. So as long as you're only working on the UI, you only, debug it on macOS. You see the UI, you create it. As soon as you need something platform specific, you can, you then have to run it on the device, of course, but nothing special from there on, nothing more to see. We have our embedded device built here. We have our solution to the M&M problem. We can now, select how many portions of M&Ms should come out. We have a M&M portioner, and that's already it for the talk. Thank you very much.